Okay, right. So distance between core centers. Okay, this question we had done. Calculate the kVA output of a single phase transformer from the following data. Okay, and we did this one also, right? Okay, this one we had done. Example number 5.3. Let's calculate the kVA output of a single phase transformer from the following data, and we had applied the equation for Q, and we got the value of Q equal to 450 kVA. Okay. The next question is example number 5.4. Okay. And let us move to the next question. So the question is, determine the dimension of core and yoke for a 200 kVA 50 hertz single phase core type transformer. I hope my voice is audible to you. Okay. I hope my voice is audible. You can just reply me into the chat box if my voice is audible. Right. Okay. So determine the dimension of core and yoke. Determine the dimension of core and yoke for a 200 kVA 50 Hz single phase core type transformer. A cruciform core is used with distance between adjacent limbs equal to 1.6 times the width of core lamination. Assume voltage per turn 14 volt, maximum flux density 1.1 Weber per meter square, window space factor as 0.32, current density as 3 ampere per millimeter square, and stacking factor equal to 0.9. The net iron area is 0.56 d square in a cruciform core where d is the diameter of circumscribing circle. Also, the width of the largest stamping is 0.85 d. Okay, so let us do the so just try to solve this question. Okay, you can just write down this question, take a snapshot for further reference. Okay, the dimension of core and yoke that you have to find out. Okay, and the rating of the transformer is given as 200 kVA 50 hertz single phase core type transformer. The type of core we are using is the cruciform core, and distance between the adjacent limb is equal to 1.6 times the width of the core lamination. The voltage per turn is given as 14 volts. Maximum flux density is given as 1.1 Weber per meter square. Window space factor is given as 0.32. Current density is given as 3 ampere per millimeter square. And stacking factor is equal to 0.9. So the net iron area is 0.56 d square. Okay. So we have these options here. So just note down this question. Okay, so just note down the question. Okay, and we shall try to solve this question. So let us move towards the whiteboard. Okay. So hope you are able to see the whiteboard, and let's try to do the question. Okay. So now we know that the in this question. Okay, I hope I am audible to you, and you are able to hear me. I think you are able to see the whiteboard also. Okay, right. So now let us try to do this question. Okay. So now we know that we have the voltage per turn is given. The voltage per turn. Okay, the voltage per turn is given. Okay, so we know that. Okay, right. So I hope the screen is visible to you. Okay, and you can see my screen also. Okay, right. So let us do the numerical. So the voltage per turn is given as E equal to, okay, EI is equal to 4.44 into the frequency in hertz into the maximum flux phi m, which can be written as 4.44 F into Bm into AI. Okay, so then we have uh, net iron area. Net iron area AI is equal to 14 divided by 4.44 into 50 into 1.1, that is equal to 0.0573 meter square. Okay, so okay, so this is because we already know that we it is given here that EI is already given as 14 volt. Okay, voltage per turn is 14 volts. So EI is already given as 14 volts. So that's why we are using this formula and we can get our AI, which is the net iron area. Okay, and then what we have to do is we have to find the diameter of the circumscribing circle. Okay, so therefore the diameter of circumscribing circle, okay, diameter of circumscribing circle d, small d, is equal to under root of AI divided by 0.56, which is equal to 0.0573 divided by 0.56 root. Okay, so in this way we can find our d here is equal to 0.32 meter, right? So we got the diameter of the circumscribing circle, right? Okay, so I hope you understanding the question, that how we can do this type of question. Um, the other part, we have to find all the dimension. We just need to find all the dimension of the core and the yoke. Okay, in this question. Okay, so let us find the width of the largest stamping. So width of the largest stamping, width of the largest stamping, which width of the largest stamping A is equal to 0.85, 0.85 into D. Okay, which is equal to 0.85 into 0.32, that is equal to 0.272 meter. Okay, so in this way we can find the width of the largest stamping A equal to 0.85 D, that is equal to 0.85 into 0.32 equal to 0.272 meter. Okay, and then distance between core center, distance between core centers, distance between core centers, capital D will be equal to 1.6 A, which is given. Okay, so this can be written as 1.6 into the dimension of A, we can put, so A is equal to 0.272 meter. Okay, that is equal to 0.435 meter. Okay, right? So just you can note down this part. Okay, and then we'll move to the other part. Okay, so just note down this part. Okay, right. So width of the window is WW equal to D minus D. Okay, the width of the window WW is given as D minus D. We know that the value of D is equal to 0.435 meter, and the value of small d is equal to 0.32 meter. So width of the window WW is given by 0.435 meter minus 0.32 meter, that is equal to 0.115 meter. For a single phase transformer, we have the equation that Q is equal to 2.22 into frequency into Bm into the winding factor Kw into delta into Aw into Ai into 10 to the power minus 3. So we know that in the question Q is given as 200 kVA. So we are equating 200 kVA with the this formula 2.222. Frequency in India is 50 hertz. uh, Bm is given as 1.1, Kw 0.32, delta is 3, and AW we had to find. AI we got 10 to the power 6. Okay, 0.0573 is the AI. Okay, and equating all this thing, we got our window area AW is equal to 0.0298 meters square. Okay, so till that we have done this question. Okay, I think our Zoom time will be running out, so I will be sharing you another Zoom link. Uh, okay, so you can we can further do some problems in this class. Okay, so if we run out of time, don't worry, I will be sharing you. I think there are 6 minutes is remaining. Okay, after that we shall be I will share you one more link. Okay, and then we might be able to do. So I hope that my voice is audible and the board is also visible, and you can see the class also. Okay, right? Okay. Now further we can. Okay, you can write down your roll numbers in the chat box so that I will be taking the attendance, because in Zoom we have recording also, no? So we can just get the chat text. From that we can obtain all your roll numbers, those who are present. So please write your roll numbers in the chat box, everybody, so I may know that who are present or who are not. Okay, so everybody can write your roll number, and then you can just write yes, yes, or present, present, something like that, so that I can mark your attendance. Okay. Right. Thank you so much. Okay. So you can write your roll numbers, everybody, because attendance is important, right? And your midterms are also coming, and you need to you need to do well. And I think you will be getting very good marks in your midterm. Don't worry about that. Okay. So window area AW is equal to 0.0298 meters square. And then we can then also find the height of window. Height of window HW, that can be written as 0.0298 divided by 0.115. That will be equal to 0.26 meter. Okay. So HW will be equal to 0.26 meter. Then we have to find the depth of yoke. Okay, so let us move to the next page. Okay, this page is already saturated. Okay, so now we are using the same stepped function, using the same step section for the yoke. We are using the same step section for the yoke as for the core, because we have to find the dimension of the yoke also. So the sections are same for the yoke and the core. So we can take the same dimensions here. And then depth of the yoke. Depth of yoke d shall be equal to, okay, we can take this d as dy. The depth of yoke dy can be written as the side of a square, which is equal to a, that is equal to 0.272 meter. And since it is a square, so so our height will also be the same. Okay, so height of yoke hy will also be equal to a, so that is equal to 0.272 meter. Then we need to find the overall height of frame and overall length of frame. Okay, so height overall height of frame h is equal to hw plus 2 hy, that is equal to 26 plus 2 into 0.7, sorry, 0.2, I think it is 0.2, let's rub it, so 0.272. Okay, so then our overall height h can be equated to, it can be calculated to the value of 0.804 meter. Okay, so that's good. That is our overall height of the frame. Nice height, 0.804 meter. Now let us find overall length of the frame. So overall length of the frame W can be also written as d plus small a, and we know that the diameter d